Good morning, students. This is Lecture 5 of Mathematics Class 8, Chapter 10, Visualizing Solid Shapes. Let us see what are the key points of this lecture. First one is recapitulation of previous concepts. Faces, vertices and edges. Though we have learnt it in the previous lecture, but to understand one important concept of this chapter, we need to review faces, vertices and edges again. Euler's formula. This is a very important concept of this chapter. So the key points of this today's lecture are recapitulation of previous concepts, faces, vertices and edges we will revise, and we will learn a new concept, that is Euler's formula. Now coming to faces, edges and vertices. What do you mean by faces? Flat surface of a solid is called its face. Solids have more than one face. So what are faces? Flat surface of a solid is called its face. Solids have more than one face, or we can say the polygonal regions forming a polyhedron are called faces. The polygonal regions forming a polyhedron are called faces. So what do you mean by faces? Flat surface of a solid is called its face. Solids have more than one face. For example, cube and cuboids have 6 faces. Or we can say the polygonal regions forming a polyhedron are called faces. Coming to edges. What do you mean by edges? Line segment which acts as an interface between two faces is called an edge. So what do you mean by an edge? A line segment which acts as an interface between two faces is called an edge. It is the line segment that joins two vertices. So line segment which acts as an interface between two faces is called an edge. It is the line segment that joins two vertices. For example, cubes and cuboids have 12 edges. So what do you mean by faces? Flat surface of a solid is called its face. Solids have more than one face. For example, cube and cuboids have 6 faces. Edges, line segment which acts as an interface between two faces is called an edge. It is the line segment that joins two vertices. For example, cube and cuboids have 12 edges. Coming to a vertex. A vertex is a point where two or more edges meet. These are the corner points. What do you mean by a vertex? A vertex is a point where two or more edges meet, and these are the corner points. For example, cubes and cuboids have 8 vertices. So vertex is a point where two or more edges meet. These are the corner points, and cube and cuboids have 8 vertices. Let us see with the help of this figure. In this figure, I have tried to show you the faces, edges and vertices very clearly. So I am repeating it. Faces are the polygonal regions forming a polyhedron are called faces. Edges, what are edges? The line segments where the faces of a polyhedron meet are called edges. And what do you mean by vertices? The points where the edges of a polyhedron meet are called the vertices, or these are the corner points. I hope you have recalled it well now. What are faces, vertices and edges? Now, we have studied about prism in the last lecture. Let us revise it once again. What do you mean by a prism? If the top and bottom of a polyhedron are congruent polygons and its lateral faces are parallelograms in shape, then it is said to be a prism. So what do you mean by a prism? A polyhedron, or you can say like this, a polyhedron whose base and top are congruent polygons and whose lateral faces are parallelograms in shape is called a prism. These are the two figures of a prism. Here, first one is a rectangular prism, and I told you that a prism is named after its base. If the base is a rectangle, then it will be a rectangular prism. If the base is triangle, then it will be a triangular prism. If the base is a pentagon, then it will be a pentagonal prism. If the base is hexagon, then it will be a hexagonal prism. So we have studied about prism. And let us revise now, what do you mean by a pyramid? A polyhedron whose base is a polygon of any number of sides and whose lateral faces are triangles with a common vertex is called a pyramid. So what do you mean by a pyramid? A polyhedron whose base is a polygon of any number of sides and whose lateral faces are triangles with a common vertex is called a pyramid. These are the two figures of a pyramid. Base, as I told you earlier also, the pyramid is also named after its base. So in the first figure, it is a rectangle, base is a rectangle. So first one is a rectangular pyramid. Second one, in the second figure, the base is a triangle. So it is a triangular pyramid. So what do you mean by a prism? A prism is a polyhedron whose base and top are congruent polygons and whose lateral faces are parallelograms in shape, then that polyhedron is called a prism. And what do you mean by a pyramid? A polyhedron whose base is a polygon of any number of sides and whose lateral faces are triangles with a common vertex is called a pyramid. We have learnt about types of prisms also. These are the three types of prisms. It can be more than that also, because it depends on the prism is named after its base. So I told you earlier also, if the base of the prism is triangle, then it will be a triangular prism. So what do you mean by a triangular prism? A prism whose base and top are congruent triangles and lateral faces are rectangles is called a triangular prism. Then what do you mean by a rectangular prism? A prism whose base and top are congruent rectangles and lateral faces are rectangles is called a rectangular prism. It is also called a cuboid. Coming to hexagonal prism, a prism whose base and top are congruent hexagons and lateral faces are rectangles is called a hexagonal prism. I hope you must have recalled it well now. So, coming to types of pyramid. We have studied about triangular pyramid, rectangular pyramid and hexagonal pyramid. So, what do you mean by a triangular pyramid? A pyramid whose base is a triangle is called a triangular pyramid. Or we can say a polyhedron whose base is a triangle and whose lateral faces are triangles with a common vertex is called a triangular pyramid. We have also studied about tetrahedron. Basically, tetrahedron is a special type of triangular pyramid in which all the faces are equilateral triangles. So, I hope this is very much clear to you now. Tetrahedron is a special type of triangular pyramid in which all the faces are equilateral triangles. Coming to rectangular pyramid, a pyramid whose base is a rectangle is called a rectangular pyramid. Or we can say a polyhedron whose base is a rectangle and whose lateral faces are triangles with a common vertex is called a pyramid. Similarly, we can define hexagonal pyramid. So what do you mean by a hexagonal pyramid? Hexagonal pyramid is that pyramid whose base is a hexagon, or we can say a polyhedron whose base is a hexagon and whose lateral faces are triangles with a common vertex is called a hexagonal pyramid. Now coming to today's lecture concept, that is Euler's formula. This formula basically shows the relationship between edges, faces and vertices of a polyhedron. We have revised these, what are faces, what are edges and what are vertices. So on the basis of that, we need to learn or we need to develop a relationship between these three that is given by the formula, that is Euler's formula. Every polyhedron will satisfy one criteria, that is the Euler's formula only. So this will be f plus v should be equal to e plus 2. For a given solid to be a polyhedron, this criteria should be satisfied. If this criteria fails, then the given solid is not a polyhedron. Where f is the number of faces of a polyhedron, v is the number of vertices of a polyhedron, E is the number of edges of a polyhedron. So Euler's formula gives the relationship between edges, faces and vertices of a polyhedron, and every polyhedron should satisfy this criteria f plus v is equal to e plus 2, or it can be written in another way also, f plus v minus e is equal to 2. Both are the same things, because when e will be shifted to right hand side, it will be e plus 2, where f is the number of faces of a polyhedron, v is the number of vertices of a polyhedron, e is the number of edges of a polyhedron. Now let us see an example how to use this Euler's formula. For example, using Euler's formula, find the number of faces if the number of vertices is 6 and number of edges is 12. In this exercise 10.3, you will find these types of questions, and few questions will be of the type that everything will be given to you, like faces, vertices and edges will be given to you, and you need to tell whether can a polyhedron have, for example, I am telling you, can a polyhedron have 15 faces, 30 edges and 20 vertices? In this case, you are supposed to use the Euler's formula. This is one of the type of the question given in exercise 10.3. This is the another type which I am showing it on the screen, like find the number of faces if the number of vertices is 6 and number of edges is 12. Using Euler's formula, you can determine the three quantities. It is a relationship between three quantities. If two quantities are given to you can find out the third one, that is the unknown one. So what is the how you will solve this? V is equal to 6, where V is the number of vertices of a given figure, and E is equal to 12. So we know the Euler's formula, that is f plus v minus e is equal to 2. So putting the values, f will remain f. You can write f here, or you can take any unknown quantity like x, y, z, a, b, c, or whatsoever it is. You can let it be f also. So f plus 6 minus 12 is equal to 2. So it will be f minus 6 is equal to 2, and hence f will be equal to 8, where f, v and e are the faces, vertices and edges of a given solid or given figure. I hope this question is clear to you. So, few solids, I am showing you one table which will help you to know the faces, vertices and edges of few solids. Like this is one of the table. For cube, number of faces are 6, number of edges are 12 and number of vertices are 8. Likewise, rectangular prism, number of faces will be 6, number of edges will be 12 and number of vertices will be 8. Triangular prism, number of faces 5, number of edges 9 and number of vertices are 6. Pentagonal prism, number of faces are 7, number of edges are 15 and number of vertices are 10. Similarly, hexagonal prism will have number of faces 8, number of edges 18 and number of vertices 12. Likewise, this table can help you to know the number of faces, edges and vertices. Now, few students may not be able to find the faces, edges and vertices using the given figure. So, I am telling you an example that will help you to find the number of faces, vertices and edges. Suppose I have prism and pyramid. Only two figures will be given to you. To find the cube and cuboids are very well known to you. So I think you will be facing problem in finding the number of faces, vertices and edges in hexagonal or in a prism or a pyramid. I have tried to show you the example of both these, how to find faces, vertices and edges. So coming to first part, here in this example I have taken two parts. First one is hexagonal prism. Coming to this part, in hexagonal prism, first of all, hexagon, what are the number of sides of base? Hexagon, everyone knows, number of sides of base is 6. This is the figure of this hexagonal prism. Now, number of faces will be 6 plus 2. Number of sides of the base is 6. So, you are supposed to add 2 to find the number of faces. That will be 8. Number of vertices. How will you find out number of vertices? You are supposed to multiply the number of sides, that is 6 here, into 2, that will give you 12. Number of edges, 6 into 3, that will give you 18. I hope that is very much clear to you. Now coming to pentagonal pyramid. This is the figure of a pentagonal pyramid. Now in pentagonal pyramid, pentagon, how many number of sides of the base? 5 are the number of sides. Number of faces in this pyramid, you are supposed to add 1 to the number of sides of the base to find the faces. Number of vertices, how will you find? Again you are supposed to add 1, that will be 6, 5 plus 1, 6. Number of edges, you are supposed to multiply the number of sides of the base by 2, that will give you 5 into 2, 10. So for a prism and for a pyramid, F is equal to S plus 2. For a prism, it is S plus 2, where S is the number of sides of the base. We have learnt in hexagonal prism. So number of faces in hexagonal prism were 6 plus 2, that is equal to 8. 6 are the number of sides of the base, that is 6. So 6 plus 2, that is 8. In pyramid, it will be it is a pentagonal pyramid, so it will be 5 plus 1, that is equal to 6, as it is shown above also. Then to find vertices, in prism you are supposed to multiply it by 2. Number of sides should be multiplied by 2, and for a pyramid you are again need to add 1 to the number of sides of the base. For edge, to find number of edges, for prism you are supposed to multiply number of sides of the base by 3, and for a pyramid you are supposed to multiply number of sides by 2. I hope with this given table for a prism and pyramid, you are supposed to learn this table, and this will help you to find the number of faces, vertices and edges for a prism and for a pyramid. So to find the number of faces, vertices and edges, first of all you should know the number of sides of the base of the given figure. Here I have taken a hexagonal prism example and a pentagonal pyramid. So hexagon, number of sides of hexagon are 6, of base is 6, number of sides of base of pentagon is 5. So accordingly, if you learn this table, if you learn this relationship between S and faces, vertices and edges respectively for a prism and pyramid, you will be able to find faces, vertices and edges very easily. So let us see what will be the homework now. You are supposed to complete exercise 10.3 in your homework notebook. All the questions will be based on the Euler's formula, which we have studied today, and you will be able to do it very easily. All the concepts, all the questions based on the concepts taught in this lecture. So now today what we have learnt, we have revised faces, edges and vertices again, because that plays an important role to study Euler's formula. So what are faces? The polygonal regions forming a polyhedron are called faces. What are edges? The line segments where the faces of a polyhedron meet are called edges. What do you mean by vertices? The points where the edges of a polyhedron meet are called vertices. And we have learnt about Euler's formula. What is that formula? This formula shows the relationship between faces, vertices and edges of a polyhedron, and if this and what is this formula? F plus V is equal to E plus 2, or F plus V minus E is equal to 2. That is both are the same equations. You can solve and you can use any one of these. And if a polyhedron is not, if a solid is not satisfying this criteria, then that solid is not a polyhedron. And we have revised prisms, pyramids and its various types. I hope you will be able to solve the questions on the basis of these concepts. Coming to homework solutions, students, I have given you to solve 3 questions. One question was supposed to be done in the book, that was question number 3, and question number 4 is also very easy, so you can do it on your own. I hope you must have done it. I am explaining question number 5, that is a square prism same as a cube? You are supposed to explain this. Every square prism cannot be a cube. It may be a cuboid also. I told you that prism is named after its base. So if the base is a square, the lateral faces are rectangles or parallelograms, so it can be a cuboid also. I hope you have understood all the concepts taught in today's lecture. Thank you so much.